Okay, all right. Time to get started. So, welcome to Math 212. I hope everyone here is here for Math 212. Cool. All right. By the way, this is my first time teaching in this classroom in years. Last time I taught in this classroom, they did not have this same projector set up. It wasn't on this side of the room, and it wasn't this big. This is the biggest screen that I've ever worked with in a non-auditorium setting. So, okay, all right, there we go. There's always issues first time. Let's see what just happened here. Oh, I think it switched. The input switched for some reason there. Okay, all right. Hopefully the recording's still going. Let me just double check. So that segues very well. We are video recording this lecture. I always video record all my lectures if I can, if the opportunity presents. So this is one of those times, and I'll say some more words about that in a little while. But anyway, you've been officially informed. We are recording this. What's being recorded is what's on my screen, which is identical to what's on this projector screen, and audio, right? Anything that the microphone of my laptop can pick up. So mostly that's going to be my voice, but if you are close to the microphone, or if you ask a question loudly, wherever you are in the room, you are going to be picked up. So again, I'm required by law to inform you that you are being recorded. Yeah. Okay, so I have some introductory comments. This ends up taking a while to go through. There's just a bunch of stuff that I think everyone needs to hear said. A large part of things that you need to know in this course are on my website. Right? So I want everyone to go and read all the discussions on my website. I'll talk about that in a moment. But some of these things are just, I think, particularly important and need to get said verbally, and you need to hear it. Right? So the first thing, real quick, any chance, if anyone here is thinking about the possibility of maybe a math major, even a math minor, it'd be a really good idea to come talk to me as soon as possible, just to think, so we can think through, is this the right course for you? Probably is, but anyway, might not be. And what other maybe considerations, depending on your situation, might be worth thinking about right now. So anyway, possible math majors, please come talk to me. After class would be fine. Okay. So the class website, this is sort of a landing page that I use for all of my courses, which I have already pulled up. That's not it. Hang on. Where is it? Where'd it go? Oh, yeah, I had it on a different tab here. Okay. This is that kind of landing page. So it's a single page that I can always put out, and I just keep all of my recent courses linked here. So right here, this is supposed to say 2018. Sorry, that's a typo. I'll get that fixed. That's supposed to say 2018. And term 2. You're just going to click right here, and it's going to take you to our website for this course as soon as I get it up, which as of right now it's not. So I'm going to show you instead the website for last term. This is from the first half of the summer, and the one for this term is going to be practically identical, different dates and stuff. But my office hours are going to be different because the class meets at a different time. This class meets 9:30 to 10:45, so my office hours are going to start at 11. Right, so right after class is over, I give myself a minute to breathe, get a drink of water, and then I'm going to be in my office, ready to answer questions for an hour after that. Yeah.
Can we also do, I guess, personal office hours by appointment?
By appointment, if it's concerning something other than math questions. If it's math questions, then I need you to come to office hours. In addition to office hours, is also the help room. Right, so the help room is going to be open for some yet to be determined, but probably on the order of 20 hours a week. It'll probably be in the afternoons. Let me take a wild, and don't quote me on it, guess of something like 1 to 5 every afternoon, something like that. So there will be other resources other than my office hours, but my schedule is too tightly packed in to be able to do one-on-ones. Yeah, all right. Unless it's something about something not directly about math questions. If it's about if it's about your major, if it's about your standing in the course, something that really does need to have private discussion, absolutely send me an email. Yeah. Okay, so let's see. The textbook, it's my textbook, And you can click here for, oh, by the way, I made a new web page. Oh, what's going on? And I didn't do my web page right. Okay, hey, let's try that again. Why isn't that? All right. I'll figure that out later. Anyway, if you don't already have a copy of the book, let me know and I'll send you the link for where to order it on Amazon. But it's an Amazon order. Okay, it's not available in the bookstore. So there's 4 links here in the course information section. I need you to make sure to look at and read all of the content on these 4 links. This one here, general comments. Ow, come on, you're killing me. I don't know why the math department server is down. But anyway, I will get this fixed. But there's a lot of discussion on these pages that you need to absolutely be sure to make sure to read. You're responsible for knowing all the discussions, all the content of all the discussions on those 4 pages. And then also, please flip through the main page here. There's some discussion here of exceptions to the earlier discussions as it pertains to summer classes. So summer classes run a little bit differently. So there's 2 midterms, not 3 midterms. 3 midterms from the semesters, but summers happen so fast it just doesn't really make sense to do 3. Homework is collected every day, blah, blah, blah. Make sure to read these details. Okay. All right. So yeah, all the main page, all the links in the course information section. And by the way, this is not just, stuff that looks good on paper. Right? This is all very relevant and factual and literal about how this course will run. So please do take it all literally and seriously. Click around on the links. You don't have to, read and study every single link on every single page, because there's several things that I link to that I think are useful for you to have a reference to. You don't need to read everything in all those links, but you do need to know what's there. I mean, it's a good idea to just kind of click around and see what I've got there for you. Certain documents I think you should print. The syllabus. Right? It's a good thing to have a printed copy of, or some other extremely convenient access that you might arrange. I don't know, you could make it your computer's wallpaper or something like that if you prefer. But you're going to be referring to that every day for what homework questions are assigned, that kind of thing. Okay. The lecture schedule is going to show, and I'd show you the document right now, but it looks like I don't have internet access. So the lecture schedule is going to show what we are planning to cover on any given day in the course. It'll also indicate when the exams are, and I'm going to have some buffer days factored in, because we'll never, sometimes we're a little ahead of schedule, sometimes we're a little behind schedule, more often behind. We always catch up at the end. It's all going to work out, nothing to worry about. But anyway, what we're planning to do on any given day on the lecture schedule. Okay. Resources. It's a little cheesy to say this, but you are your own primary resource in this course. This is largely for dramatic effect. I just want to point out that you're in charge of your own education here, and I hope I can help, right? But you're in charge, and so you have to aggressively push yourself to make sure that you, in fact, are understanding all the ideas that we're talking about. If you're not understanding, I won't notice until the exams, right? And by that time, it's too late for at least for that exam, right? So you have to, be aggressive and thinking about, wait, am I really getting this? Am I ready to take an exam on this topic? Because I won't be able to. Okay. I hope the book will be a good reference. Again, I wrote the book. I like it, obviously. I'm biased, right? But anyway, for whatever that's worth. I do encourage you to read the appropriate sections of the book before you come to class. I'm a big believer in layers when you're learning a topic, especially math. But don't plan to just, learn it all in one great big setting, right? Put down a thin coat first, understand, kind of the big picture, see what the questions are, roughly the plan of attack, and then a second layer on top of that of dig in for a few more details and try to understand, all the ins and outs of the equations, and then another layer on top of that of what makes it possible for this to work. Do we need to worry about whether these functions are continuous? What happens if this function is continuous but not differentiable. Does it still work, or does the thing crash and burn? And so, more sophisticated details, right? So I think it's good to do this in multiple layers and not, again, sort of all at once. I don't know if any of y'all have ever done any painting or staining or anything like that. But if you just put down this great big thick, if you just take the bucket of paint and throw it on it doesn't work well, right? Thin coats. So here, read the book before you come to class. First thin coat. Right? You're not going to understand everything. You're not supposed to understand everything. But you're supposed to see roughly what the question is, roughly what the strategy for the answer is. Develop a bunch of questions in your mind. What do I hope he talks about? Because I don't really get what he said here in the book. That kind of thing. Then, of course, you come to class. That's your second coat. Hopefully I'll be able to help you in explaining, in lecture. And then again, third coat. Read it after class. Right? Don't just go straight to the homework exercises, which of course you can do, but I think it's a good idea to read through the section again, and this time think about, from the perspective of what you learned in class, what hopefully was clarified in class, and try to fill in those blanks. And then arguably you could read it all again, and as part of your preparation for the exams, something like that. Anyway, multiple layers. Another reason to read is that I will not be doing everything in the book in class. There's not enough time. Just not enough hours. So I will be making choices as to which examples I think are worth doing and which examples you guys can just read on your own, should be fine. And some tough choices involved with that. So be prepared that I won't. Just because I didn't do that example in class does not mean that you don't have to know it. You're responsible for everything that's in the book, unless I explicitly say otherwise. You're also responsible for everything that happens in class, even if it's not in the book. Right? And etc. Okay, yeah?
Can I ask that question?
Please.
Will you, you won't be covering everything in the book, but will you cover each individual section to some extent, or will there be, full sections?
There is one section near the end that it's kind of a 50-50 as to whether I'll be able to get to it, and it's not mandatory, and it's in the book because I'd rather have the option than not have the option. But so there might be some sections, full sections that I won't cover, but I will make it extremely clear which ones are which. And the vast majority of sections in the book we are going to cover. Okay. Again, notice I list myself third on this list of resources. All right, so I hope I can help, but don't count on me to just magically make it happen, right? So now, obviously, if I'm going to help, you have to come to class. So along those lines, class attendance is required. I will start taking class attendance explicitly in a few days after drop ad ends. There's kind of no point in doing it before drop ad is over. And it will count as part of your grade. Not a lot, but definitely a little bit. And it's definitely one of these kind of borderline, if you're right on the, it could go either way. Good class attendance tends to bump you up. Bad class attendance, maybe not. So anyway, keep that in mind. By the way, another reason that I have to make attendance count is because of the video recordings. The very first time I started doing video recordings of my lectures, my class attendance took a serious nosedive. Down to 20, 30%. Yeah. And I had to make the decision that, look, this is not the University of Phoenix, and we're going to actually have a physical, present class, right? And students who want to just, use this as a sort of an online course, that's not what we're doing, and it's importantly not what we're doing. So anyway, so I have to, now of course once I started counting attendance shot right back up. Right? Okay, fourth resource, classmates. I'm a big believer in study groups. Doing your homework in a group. I think that's great. I did a lot of that when I was in college. It was a big help. You got 3 or 4 people sitting around a table, all working on the same questions at the same time. Somebody gets stuck, somebody else can help them. Right? This is a big win both ways. If you are the person who's stuck, you get help. That's super, right? What you might have not thought through, but if the other person needs help and you help them, this is a tremendous learning opportunity for you. because you get the practice of explaining the ideas. You probably notice that there's sometimes you feel like you understand an idea, but you're trying to explain it to someone and you're not exactly sure how to say it. It doesn't come out quite right. That is an indication that you have a superficial, unset understanding of these ideas, right? So take it seriously if you cannot explain why something is true, because that's a problem. You need to be able to explain it succinctly, clearly, crisply, confidently, if you want to have a really good understanding of the idea. So anyway, it's a great idea. It's a win-win if you're working on the homework in groups. I do want to clarify one thing about working on homework in groups. Everything that you turn in does have to be your own work, right? I hope that seems natural. By which I mean you cannot take the homework assignment, cut it into thirds. Everybody does their third and then copies the other two, right? Come on, that's obvious, right? So it is fine for you to get to number 12 and think, I don't know what to do here. Steve, help me out, right? And Steve helps you and tells you exactly how to do the problem, explains all the ideas. Fine. You've got to then, that's got to get into your head, right? And what you write down has to originate in your head, right? You can't copy Steve's work, and you can't just transcribe Steve's words. You've got to understand it and say it your own words. So I hope that seems clear. It's not unlike the issue of plagiarism, right? So anyway, all right. Expectations. I mean, there's a lot to talk about on this. There are 3 different levels of proficiency I expect you all to have. The first one is obvious. Yes, of course, you need to have memorized certain formulas. Sure, of course. Right? No surprise. Yes, of course, you need to know how to execute certain algorithms. Well, every math class you've ever taken, you have to execute certain algorithms. Okay, that is item number 1 only. That is not the end of it, right? If you just memorize certain algorithms and memorize certain formulas and walk into the test, you're going to get crushed. Because that's not what we do here. It is important that you, really, no kidding, understand what these formulas mean. What does this construction do? What is it? What's the geometric motivation or physical motivation for why we write these things down? Why does this particular algebraic expression do what we claim that it's going to do? Right? There's understanding to be had. And then even more than that, the way we test understanding, partly, but also the way we test whether or not you're ready to do whatever it is that is the reason why you take this course in the first place, is we're going to test whether you can apply the ideas, the understanding, not just, can you take an algorithm to be executed on top of, some situation, but can you apply the ideas to an unfamiliar situation? And I think this is worth emphasizing. Unfamiliar. Right, so I'm not going to just put on the test the same physical scenarios down to a T, right, that we talk about in class, or the same geometric scenarios. I'm going to come up with something that's, it's in the same direction, but it's definitely different. The only way you can deal with that, the only way you're going to be able to answer questions that ask you to apply ideas to unfamiliar situations is if, in fact, you understand the real ideas, down deep, right? As opposed to, again, if all you've done is this, then there's no chance. It wouldn't make any sense. You're like, I've never seen this before. I don't know which algorithm am I supposed to brainlessly execute here, right? So make sure that you think about this as you are going through the material, that this is going to be on the exam, and make sure you're prepared appropriately. Okay, now, here's a question that comes up a lot. Why can't I just memorize algorithms? What's wrong with that? Isn't it useful to be able to have memorized and be proficient in executing certain algorithms? It is useful, and by the way, you are going to have to memorize certain algorithms, and you are going to have to be able to proficiently execute certain algorithms, as per step 1 up there, right? The reason this is not enough, one point of view anyway, is this, Wolfram Alpha. I hope you all are familiar with Wolfram Alpha. How many people have seen Wolfram Alpha before? Okay. If you haven't, Wolfram Alpha will do lots and lots of mathematical algorithms for you. Right? It's remarkable. I'm just going to show you one here. Let's see here. Plot. Okay. Well, somebody's got one typed in for me here already. Plot sine x cosine y. So this is a function of two variables, and notice there's no weird syntax that you have to know. This is not a programming language, but it can be. If you want to do really intricate stuff, you can treat it as a programming language, and it's precise. But if you just type in kind of casual talk for what you want it to do, there it is. It has given you a nice three-dimensional plot of this multivariable function. It will do integrals and derivatives, chain rules, substitutions, trig substitution. I mean, it will do a lot of stuff. So here's the way I like to say this, and this is largely for dramatic effect. Okay, suppose that your mathematical proficiency as you leave Duke is that you are able to simply execute certain algorithms. Right? That's what your mathematical proficiency is. You can execute algorithms. Then you are simply an alternative. You are a slower, less reliable, more expensive alternative to a free website. Right? So that doesn't, what do you bring to the table? Why should my company hire you? Right? We can already do execution of algorithms for free. It's not even hard to use the website, right? So you need to have something that Wolfram Alpha can't do. Does that make sense? Anyway, like I say, it's for dramatic effect largely, but I think it's a really good point. Second question that comes up. All right. So how about just show me exactly the ideas I'm going to definitely need to understand, and show me the applications that I'm going to be working on. I'm going to be an engineer, I'm going to be an economist, whatever. Just show me those specifically. What do I need to do to be an engineer? Well, I can't, because I don't know what you're going to be working on as an engineer. I don't really know exactly what engineers are working on now, but I definitely don't know what engineers are going to be working on 5 or 10 years from now. Right? When those of you who are engineering majors, when you're in a career as an engineer, what kind of stuff is engineering going to be interested in at that time? I don't know. Right? So I can't just show you those applications. They are not yet identified. So what I can do to prepare you for the yet-to-be-determined applications that you're going to be working on in your career or grad school, whatever, right, is I can help you understand ideas broadly so that you can then apply that understanding to the, as of right now, unfamiliar situation that you will be faced with in the future. Does that make sense to everybody? Okay, so this is the only reasonable strategy. If I have you just execute and memorize and execute a bunch of algorithms, then that's not worth anything. Okay. So along these lines, on the exams, we're going to be interested in, I'm going to be interested in the ideas that you communicate on your answers to exam questions. The process that you demonstrate. Are you taking a reasonable, a potentially successful approach to the problem? Do you communicate your ideas clearly? Right? So I'm going to be looking mostly at these kinds of things on grading exams. And the numerical result, whether or not you get the right actual number down at the bottom of the page and put a box around it, that's worth something, but not that much really. Right? I was grading the final exams for term 1 just a few days ago, and it happens every term that there's this wide range. Some students take this point seriously and give me, they explain their ideas, they show all their work and process, they give clear explanations, and then there's a little arithmetic boo-boo or, algebraic, these terms, there was 10 terms and one of them, oops, disappeared, and come on, it happens to the best of us, right? That's 9 out of 10. Right? On the other hand, there are always some students where there's no communication of ideas, the process is not demonstrated clearly, like there's only numbers, there's no variables, there's no labels on anything. It's just, the students are using the paper to avoid simply doing the problem in their head, right? There's no communication. There's zero ideas, and so therefore no clarity. And somehow they've gotten down to the correct numerical result. Now, clearly they must understand something, but they didn't do what they're supposed to do, right? Think of this as like a history essay. If the history essay says, what would have been the outcome of the American Revolution had France not intervened? If you write 5 words, however many words, England would have won the war. And that's it? That's all you're giving me? I mean, that's not a good history essay. Right? The analogy is not that far off. We want to see explanation of ideas, and whether you have the right result or a result that I agree with in the case of history. Not the point. Likewise, don't be surprised, again, along the lines of point 3, do not expect the exams to be reproductions of homework exercises. What purpose would that serve, right? That would completely not address item number 5A3 up there. Right? So, be prepared. Okay. There will be different questions on the exam. Okay, missed. Let's try that again. This is a hard thing to talk about, but I think this is really important. A lot of students, they're trying to take me seriously on these points that we're talking about, and they study to the point where they feel like they understand the ideas, and they come take the test and it doesn't go well, and they're like, what happened? Why didn't I do well? And my best shot at explaining this, of course there's different circumstances for every student, but what it means to understand something is not binary. And I think it's very important to recognize this. Comprehension is not a binary thing of either you get it or you don't get it. It's not really like that. I think there's more of a spectrum on comprehension. Right? So you can understand something up to a certain level. Someone else might understand it to a deeper level. Someone else even more deep than that. Right? So it's more of a continuous spectrum. I think it feels binary because everyone has an internal bar of what's good enough. Right? And, if your comprehension is down here, as you study and you sort of get it more and more and you see it from more different points of view, when you get up to that bar, when you get up to the point where you're like, this reminds me of learning such and such in this previous class, maybe a high school class, and I got an A in that class, and I feel like I understand this as well as I understood that, so this must be the right level of comprehension. And I'm not a psychiatrist or psychologist, but this is, my speculation. I feel like when you get up to a certain level, when you get up to that bar, that you get some sort of feeling of accomplishment and completion. And then you kind of stop, right? And, okay, I guess that's unavoidable. There's only 24 hours in a day. You're not going to get to that level. Right? I understand that. But where the bar is important. And the sneaky little nasty trick that happens, it's just the way math at higher levels works, is they keep raising the bar. Right? And so the level of comprehension that we expect from you in an Algebra 1 class in high school, it's maybe here, I don't know, something like that. And then a calculus class in high school, they should expect more. Right? A calculus class at Duke, they're going to expect more. If you all took Math 122L here and compare that to your high school calculus class, you may have noticed. Right? Math 212 is a higher bar than that. Right? So heads up, right? So whether you realize it or not, somewhere in your head you have a mental sort of bar set at as you study, you're going to get to that point, and you're going to feel like, based on your past experience, that this is what it means to understand something, and that you've got it. But the bar is now here. Right? So you got to figure out how to raise your bar, and exactly how to do that, exactly how to quantify this. Where is your current bar? Where does it need to be? What are the metric units of comprehension? There's no such thing, right? So this is very, very hand-wavy and non-quantitative. Nevertheless, I think it's a very real point. So, like I say, heads up. Now, how do you gauge your level of comprehension? I mean, you'll get some sort of a vibe for that in terms of how I present things in class. Look at my old exams. By the way, in case you haven't done some clicking around on me, all of my old exams, every exam that I've ever given in Math 212 is posted online, unprotected, completely public, with solutions. Right, so I want you all to take advantage of that as a resource. Look through, there's a lot of good study material there. They weren't, not important emphasis, they were not written to be study material. They were written as exams. Those were actual exams from actual classes, right? But in a sort of a nice silver lining situation, happens to be, as it turns out, that they are also nice study material for you guys. Okay. So anyway, you can look at the solutions that I've written on my old exams, and that should give you an idea of sort of what I'm expecting in terms of rigor and what I'm expecting in terms of communication of ideas, clarity, that kind of thing. Okay, yeah.
Has the course changed significantly since you started?
Not very much.
Okay, so all of them will be relevant.
All of them are pretty relevant. Now I will make one other observation, that there's two different categories of Math 212 classes that I've taught over the years. Oh, and a side note, the Duke course numbering system changed about 7 or 8 years ago. And what is now called Math 212 used to be called Math 103. Yeah, it was a dumb system they had. The way it worked is that all undergraduate classes were in the sort of the zeros or the 100s. Anything 200 and above was a graduate level class, and so there were students graduating from Duke having never taken a class numbered above 215. Right, and then people would get to their job interview, and it would say, "Oh, you took a class called Math 204 algebra." Oh, okay. So that some sort of like remedial math class? No, that's a graduate level abstract algebra course. It's a killer, right? So extremely deep and sophisticated. I took a class in college one time as a graduate level course called geometry. Right? And then a different time I took an abstract algebra course. It was titled Algebra 1. Because, that's the way mathematicians don't ever talk about high school algebra. Oh my gosh, are you kidding me? Algebra means, of course, abstract algebra. Right? So my college transcript says Algebra 1 and geometry. And that's differential geometry and abstract algebra, graduate level. Anyway, so the numbering system did not help of having the numbers be in the 100s and 200s. So they've now changed it, and now it's a reasonable system that goes into the 4s and 500s. So anyway, the old Math 212's old number is 103. So when you look through my old exams, you're going to see a lot of Math 103. Okay, but there's another distinction. There's multivariable calculus classes that I've taught in the summers and multivariable calculus classes that I've taught during semesters. They are different in that they use a different book. In the semesters, the entire math department is on board with a book that they've been using for 30, I don't know, maybe more years. At least 20, I'm pretty sure of. But I think longer than that. And everybody is required to use that same book. In the summertime, I'm the only person teaching multivariable calculus, so I get to use whatever book I want. So obviously, I choose my own book. So the exams are a little bit different. The content is a little bit different. It's not dramatically different. It's a little bit different. So FYI, if you're looking at exams from a semester course, they might be notationally a little bit different, or I might use some slightly different terminology, but not much. Okay, so look through my old exams to gauge, what am I expecting you to be able to produce on the exam? The solutions that I write are solutions that, this is what I was hoping students would do. Okay. By the way, I want to talk about another thing you can do on gauging your level of comprehension. And again, there's no metric unit, so I can't be precise about this. Don't take this. Well, take this as better than nothing in the absence of the ability to have a precise discussion. But ask yourself, and just be honest with yourself, am I ready to give a 15-minute presentation in front of the class on this topic? And then just, sit back and listen to your feelings, right? If your feelings say, oh, no, I don't want to, oh, my God, that sounds horrifying, right? Okay, you probably don't understand something about the material, right? If I were to ask you to give me a 15-minute talk on, I don't know, something that y'all are all very comfortable with, factoring quadratics, I don't think that's going to scare anybody, right? I mean, there's the I'm in front of a crowd aspect of the question, but do you think you can factor quadratics? Yeah, you're okay. You're going to go back and remind yourself of completing the square and blah, blah, blah. But pretty much, you're okay, right? So if I were to ask you to give me a 15-minute talk on the Taylor remainder theorem, that's you're gonna feel that, right? In front of people, really? Are they allowed to ask questions? It's a little bit of a scary thought. Okay, that is a great way to assess how deeply do you really understand something. The feeling of fear. You can use fear as a metric of comprehension, right? Or lack of fear. And anyway, like I say, just be honest with yourself. I have had some students actually do this. It was a couple years ago, but I had some students group up. They formed a group of like 5, and they're like, okay, everybody's gonna pick a topic, and everybody's gonna give a 15-minute presentation to everybody else in our little group, right? And so they got to sweat it, and they studied super hard on their topic that they're presenting. And they gave the presentation, and the members of their group got to ask questions. There was great dialogue. Everybody learned a lot. You don't have to do that, but I think it's awesome. Okay, moving along. That's no surprise. Everybody knows this is a hard class. Class has a rep. What you might not know is that, and this is sneaky, but it's unavoidable, the class accelerates throughout the term. So if you gauge, how much this class is going to take of your time by what's the first week of classes like, it's not going to be like that at the end of the last week is a lot faster, there's just more ideas. There are more ideas in the last week because we have more on which that we can build. It's unavoidable. We have more tools. We can do more complicated projects, as it were. So heads up, be prepared for this. If you are, at the limit of your ability to get things done with, this class, and gosh, I hope no one's taking a second summer class in parallel with this, but if you are, wow, okay, man, you got my email. Everybody get my email about this? It's like having a 6-course load. So, okay, just don't say I didn't warn you. But anyway, for whether it's another class or another obligation, if you're working in a lab or if you have a part-time job, whatever it is, if you're tight on time now, then you're going to be overwhelmed at the end of the semester, right? So, something to think about. This again always happens every term. I give this speech because it always happens, and students get into trouble, and I don't want students to get into trouble, right? I want everyone to have a good time. Then every term, a student comes to me in week 4 and says, I'm overwhelmed. And okay, what's the other class you're taking? Organic chemistry. Oh, God. Oh, man, what are you doing to yourself? That's literally, that happened last semester. There was a kid that was taking Math 212 and organic chemistry in one summer term. Brutal. Okay, we already talked about deeper levels. Okay, I've a couple of logistical issues. We've talked about lecture recordings. I have to say might be made because every so often this computer just decides to go home. Right? I don't know why. It just every so often it just quits. So I'm going to make my best effort to make recordings every day. The good news is that if a recording fails, I do have recordings from previous terms, and I can just send you. So it wouldn't be exactly the same as what happened in class, but it'd be pretty close. Anyway, I should be able to give you video resources for all the lectures that we're going to do. I think it's a great tool for studying. By the way, I started doing these recordings with no idea in my mind that it was going to be what it's turned into. I started it just because I was thinking, well, if a student's sick, then okay, this is a way for them to catch up on the material that they missed. And then it turned out that students were making a lot of use, studying the videos after the fact, and I started thinking, that is a really actually pretty good tool. So that's why I've continued. But just general studying throughout the course. I'm a big fan. During class, there will be stuff that you will not understand. It's going to happen, right? So what you can do is, and by the way, notice that, anyway, I claim that the whole screen is being recorded, and so you can see what time it is down here. And if you can't read that print because my thing's in the way or whatever, you can just look at your watch, see what time it is. Just write down what time it is, right? So in the notes, as we're going through material, as I'm talking about a particular whatever, if you don't understand this thing here, you just say, oh my gosh, that didn't make any sense at all. All right, 10, 12. Right, just write that down on your copy of the book, and then you could even write the date, whatever today's date is. And then after class, if you want to hear that again, maybe go back and read some other things and prepare yourself for all the prerequisite ideas for that topic. And then you want to hear, what did he say again that I didn't understand? Fast forward to this time, right, in the video, and just listen to it again, right? You've got it right there. I'm a big fan. So I hope y'all will take advantage of that. Let's see here, here it is. Okay, obviously, also, before exams, studying for exams, whatever topic you think you're having the most trouble with, maybe just watch that video recording again. While you're doing the homework, if you can't get a certain question, click through the videos. You don't have to watch the whole thing, but click through to the portion where I was talking about the stuff that seems to be relevant to that homework question you're having trouble with. The idea that you're missing might be right there in the video. Okay, we've talked about attendance already. I won't be doing attendance quizzes, so items A, B, and C here. Okay, let me do it like this. Items A, B, and C don't pertain to our class. I do attendance quizzes when I am teaching the large lecture classes, like Math 216, where there's 120 students in the class. I can't sit there and call names. It's not realistic, right? So that's my little hack way around that. But anyway, so I'll be taking attendance starting after drop ad ends. It will count toward your grade. Exactly how is, I don't quantify, but it's going to be, a small portion of the points for the class, but maybe a large portion of my interpretation of your effort in the class. So it's very much in your interest to, have a good attendance score. Okay. So last thing, this is, not quite last. The next thing is I want to encourage study groups. So if you already know some people in the class, you already have a little study group, 3 of you, you've already agreed we're going to work together, cool, you're set. If you are not, and if you would like to join a study group, you just don't have anyone to work with, send me an email. I will add your name to a list, and then I will distribute all contact information only to other people on the list. So that's the deal, right? So this is a way that you can, in some sense, advertise that you're looking for a study group, but only to other people that are also looking for a study group. So it won't be like posted on a website or something like that. Okay. I will not organize, who's going to meet with who at what times. That y'all work it out for yourselves. I'm just going to be the sharer of contact information, and then I'm out. And then y'all do whatever you want. Okay, so anyway, if you're interested, send me an email and let me know that you'd like to be included. Okay, I already sent a big email about this. By the way, if you joined the class after I sent that email multiple times, but it's been a month or more since I sent it. But anyway, if you didn't get this email, let me know. I'll make sure that you get it. But this course moves fast at summer pace. I mean, it's a fast course at semester pace, right? But it's even fast. It's 2.5 times chronologically. I think it's safer to think of it as 3 times as fast because, you just, the sink-in time, you can't accelerate sink-in time. So anyway, blinding speed in this course, so don't fall behind. You might not be able to catch up. It's so fast. The homework assignments will always be on a 2-day delay. So today is Monday. Whatever sections of the book we finish today, which we may or may not finish a section today because it's first day, blah, blah. But whatever sections we finish today being Monday, those exercises on the syllabus, as to be identified by an email that I will send to y'all, will be due 2 days later, that being Wednesday. And the idea of 2 days is after class today, whatever sections we finish, you should start on the homework now. You might have trouble with some of the questions, right? Which if you do, no problem. You can come to office hours tomorrow. Right? You can go to the help room tomorrow. You've got lots of opportunities to, get help, ask friends, whatever. Tomorrow, in the help room or office hours, you get the help you need. No rush. You don't have to scramble and get it done as you sit there and listen. I want to encourage y'all to focus on listening and understanding. Get to the point that you get it, and then go home and finish it later. That same day. That would be Tuesday. Right? You finish it Tuesday, and then you turn it in on Wednesday. By the way, homework's always due in class. It's always due at the start of class. I don't want students working on homework during class. It doesn't make any sense. So homework's due at the start of class. I'll have a maybe it'll be up here or whatever. So the 2-day schedule is really important. We have to stay on the 2-day schedule. Partly this is related to the fact that the summer pace is so fast. 2 lecture days in the summer is the equivalent of a week in the semester. Right? So if I let it drag to 4 days, now we're talking about a 2-week delay on the homework. It's way too much. Right? So I keep it at a very strict pace. There are some adjustments to the 2-day delay around exam times. I don't want y'all working on homeworks on the exam day. Anyway, that'll all be made clear on the schedule. But roughly speaking, expect a 2-day delay. Okay. We already talked about the book. The homework problems are all in the syllabus. So I wanted to talk about the permanent exercise labels. Let me see. It's up here. So let me go to the homework exercises. Okay, so here's some homework exercises. This question here is labeled in 2 ways. On the one hand, there is the standard label. The standard label there says, this is Chapter 1, Section 2, Exercise 2. And notice that these numbers are in numerical order. 1, 2, 3, 4. And so the numerical labels are always in order. The permanent exercise labels are not always in order. These permanent exercise labels I make these exercise labels as I write the exercise. Mostly wrote. But so the idea is that this chapter, it may or may not always be Chapter 1. In fact, it was Chapter 2 when I first wrote the book. I had Chapter 1 was an introduction that I decided to get rid of. So this may or may not always be Chapter 1, but it will always be Chapter V for vectors. Right? Likewise, this may or may not always be Section 2. I might insert another section before it, or who knows what. I might move it around. Probably not, but it could happen. And so it may or may not always be number 2, but it will always be Section V for vectors. And it might not always be numerically number 2. It might not always be the second one on the list. I might insert some other questions in front of it. This might turn into exercise 1.2.6, right? But it will always be exercise V2, because historically this was the second exercise that I wrote chronologically in this section. Okay, so the syllabus will always use the permanent exercise labels. Make sure to look at the permanent exercise labels only. These numbers you should basically never look at. Here, let me color code in a better way. So always look at these numbers, these labels. Always the green, never the red. Those two reasons for this. For one thing, I don't want to have to rewrite my syllabus. I don't want every instructor who uses my book to have to rewrite their syllabus just because I decided to insert a new question or I decided to insert a new section or something like that. Right? That's a catastrophe of inconvenience. Second reason is I don't want to kill the used textbook market every single time that I decide I'm going to write a new question, right? Can you imagine using a textbook where, oh, well, in my book it's exercise 1.2.2, but in this textbook it's 1.2.3, and they've updated the syllabus and it says 1.2.3, but I have to translate back, and in my old book it's 1.2.2. That'd be a nightmare of confusion, and it doesn't make any sense. So by having these permanent exercise labels in here, you can use an older copy of the book if you want to. Now, I don't encourage that. It's not an expensive book, right? I think it's good to have the most up-to-date thing. But anyway, if someone wants to use an older book, totally fine. Okay. All right. All right. So, real quick here, the summer session office asks me to take attendance on the first day of class. This is just for their own organizational purposes. So I'm just going to call names real quick. By the way, I will slowly learn your names as I start to return homework assignments. As of right now, I don't think I know any of your names. Sorry, but I will learn them over time here. Okay, so let's see here. Just give me a yes or here or whatever. Anna? Okay. By the way, if I say a name and if someone says here, but it's your name too, raise your hand, let me know, because we want to straighten that out. Amir? Yeah. Great. Diego El Mufti? No. Okay. Rebecca, let's see, Becca?
Here.
Okay. Aiden? Yeah. Haushwan? Haushwan Fu? No. Okay. Sorry, is that you? Okay. Great. Let's see here. Rose. Yeah. Okay. Darnery. Let's see. Darnery Gutierrez Hernandez. Oh, what is it? Damari. Yeah. Oh, of course it is. Yeah, I'm at that age where my eyes are playing tricks on me here. Let's see. Abi. Yeah. Jackson. Yeah. Niaz. Yeah. Hannah. Yeah. Okay. All right. George. Yeah. Faiz. Yeah. Okay. Alan. Yeah. Ben. Yeah. Rainey. I do know one student. Olivia. Yeah. Yushuan Wang. Okay, great. Did I say it right? Okay. Stefano. Okay. Natalie. Okay. Eduardo. Okay. Ben. Yeah. Zhumeng Yin. Okay. Kelvin. Yeah. And Yuang Zhu. Yeah. Okay. Okay. Cool. Okay. So I found everybody except for. Is there anyone here I didn't call? Everybody's had their name called. Okay. So there were two that I did not. One. There was one that I didn't find. Okay, cool. I'll deal with that later. Okay. All right. By the way, if I mispronounced your name, please come let me know. It's something I would like to make a note about and try to take seriously. Okay, we are done with the introductory spiel in a mere 55 minutes. I know it's a lot of stuff, but I think it's stuff that has to get said. Okay, so let's do some math. Starting in Chapter 1, Section 1, let's talk about what are points in Rn. So, said differently, what is Rn? Y'all might have heard of the XY plane. You, I'm sure, have heard of the XY plane, and this is how we talk about the XY plane. There are two axes, X and Y, that's the name. And the idea is that a point, that's a geometric thing. It's a place, right? It's not numbers, it's a place, it's a thing, geometrically. But we describe that geometric thing by numbers in a certain way. And the rule is, you do like this. And by the way, if you take Math 216, we'll say a little bit more about exactly what I mean by do like this. But in this context, you know what I'm talking about. And you identify these numbers, X and Y, and you make an ordered pair. Right? So this ordered pair here, X comma Y, that's what I'm going to call an algebraic thing. It's an algebraic thing because it's an algebraic structure, namely an ordered list of algebraic objects, namely numbers. So we have an algebraic way of describing a geometric thing. Yeah? Everybody good? Okay, old news. Same thing in 3 dimensions. And I will call this XYZ space. Because in 3 space, if you have a point, right, you can look at X, Y, and Z axes, and you can project, again, let's not be too worried about the details here, but you can look at these 3 coordinates. Those 3 coordinates then give you an algebraic description, an ordered triple of real numbers, describing that geometric object, namely a point in 3 space. Okay, so you can think of R3 as being, points in space. But algebraically, you can think of R3 as being the collection of all ordered triples of real numbers. That's just an algebraic way of thinking of the same thing. Does that make sense to everybody? So, what is Rn? Well, geometrically, whoa, scary. Right? What do you mean by even R4? It's kind of a scary concept geometrically. We can't visualize R4, and I don't believe anyone who says they can, by the way. Right? So don't let anybody intimidate you. Say, I can visualize 4 dimensions. No, they can't. They can fool themselves into believing they can visualize 4 dimensions. They cannot visualize 4 dimensions. So geometrically, it's unrealistic to try to visualize something like R4. But from an algebraic point of view, R4 is just a collection of all ordered 4 tuples of real numbers. So algebraically, it's totally easy to talk about. Now, I want to address the question of why would we ever want to talk about R4, the collection of all possible ordered 4 tuples. What does that have to do with the real world? The real world's 3-dimensional as far as we're aware, and let's not worry about particle physics, string theory, wacky speculations on maybe where you live in a 9-dimensional world. We don't need to go to that. Right? There's a much simpler reason why we need to understand R4, or more generally Rn, and that is that we do more with Euclidean space than model 3-dimensional physical world. Right? So here's a very simple scenario in which you need to be able to do math in, I'm going to say R4, just to keep it easy. Maybe you are an economist and you're interested in relating several different variables like interest rates and capital and labor and risk, and let's just leave it at that. Well, that's 4 different variables. Any given scenario that you might be interested in looking at involves knowing these 4 numbers. You are interested in doing math involving 4 variables. You're looking at ordered lists of 4 numbers. You are doing math in R4. Visualizing, right? But you are doing math in R4. And if in addition to those 4 variables, if there's, anyone who's taken an econ class knows that there can be lots of different variables. It is not at all hard to imagine that you might be doing math in R8 at some point. So this is not, I'll say it's a mistake. It's a common mistake for students to think that R2 and R3 is, well, come on, it's all you need. Unless you're doing spooky, super graduate level physics, that you don't need to know anything beyond R3. Wildly inaccurate, right? Engineers, economists, anyone who's studying variables of which there might be more than 3. 3 is a really small number, right? Needs to understand RN. Again, don't try to think about it geometrically. Your brain will melt. But you need to understand that it is simply a way of collecting together a bunch of different variables. Okay, now what's a vector? There's different things that can be thought of as vectors. I'm going to start by describing a couple of actual things that we're going to be interested in, and then we'll get to what makes them a vector. First is a displacement. Suppose that you start at a certain spot, I don't know, maybe on the map, and then you move in such a way that you end at a particular spot. Well, you have experienced a displacement, right? You move from a starting point to an ending point. When you do that, there are 2 geometric objects that we can use to describe this experience that you've had of moving, from a starting point to an ending point. On the one hand, there is a direction. Come on, man. There is a direction in which you went. You didn't go that way. You went that way. Right? Okay, so there's a direction of your displacement, and then there's also a magnitude. There's a, how far did you go in that direction? So a displacement can be described by a direction and a magnitude, for example. Now, here's another thing you might be interested in, and that is, suppose you're moving with a velocity. And velocity, you might recall from your high school physics classes, velocity is a speed combined with a direction. Well, if you think about it, there's something that has in common with a displacement. There is a direction of your velocity. There's a direction that you're going, right? And then there is a magnitude, namely how fast are you going in that direction. Now, I'm not saying that velocities and displacements are the same thing. Of course not. Completely different ideas. A velocity is a sort of an instantaneous, anyway, it's a completely different notion, right? Whereas a displacement is at times got nothing to do with a displacement. Displacement is, you started here, you ended there. It's kind of anyway, a very different thing. What I am saying is that they are described by the same 2 tools. They're both described by the combination of a direction and a magnitude. We just interpret the magnitudes in different ways. We're talking about displacement, the magnitude is a distance. If we're talking about velocity, we're interpreting the magnitude as a speed. Okay, but in both cases, they're a combination of a direction and a magnitude. And it turns out there's just lots of situations where this is a relevant construction. The pairing, the combination of a direction and a magnitude. That pair is super useful. Lots of different scenarios. Here's another one, forces. A force has a direction and a magnitude, right? This mug. I need a sip. I'm applying a force to this mug. The direction of the force that I'm applying is that way. The magnitude is, how much does this mug weigh? Right? So forces described by a direction and a magnitude. Forces are not the same as displacements. They're not the same as velocities, but they are described by the same mathematical, this pair of mathematical objects, direction and magnitude. Okay, so this pair, the combination of a direction and a magnitude, We're going to be doing a lot with these. These are called vectors. We give them the name because we're going to be doing a lot with them, because they are useful in describing so many different things. Let me go back to the things we were just talking about. We can describe a displacement as a vector. We can describe a velocity as a vector. We can describe a force. Here's my mug. We can describe the force that I'm applying on the mug with a vector. Okay, let me take a quick pause for questions. Does anybody have any questions about that? Everybody good? Okay. All right. By the way, in case you haven't noticed, I tend to talk a lot. So I want to encourage y'all to interrupt me. Just go ahead and shoot your hand up if you have a question, but don't wait for me. I do try to make conscious efforts to zip it periodically, right, and give y'all a chance to get a word in edgewise. But don't feel the need to wait for that. If you have a question, put your hand up there, and I might, say, okay, give me 2 seconds. Let me finish the thought, but I'll get back to you. Okay. All right, so how do we represent vectors? Well, I've already done it a couple times, but we use just arrows. An arrow is a very convenient way to represent a vector. Let me say that statement again. An arrow is a very convenient way to represent a direction and a magnitude because it points in a certain direction, obviously, and it has a certain magnitude in the sense of how long did I draw that arrow. Right, so the length is how we represent magnitudes with arrows, and which way we draw it is how we represent directions with arrows. So arrows are the perfect tool to represent vectors. Here's an arrow in R2. Here's an arrow in R3. Pretty much the same, right? Okay. I draw a picture of an arrow in R4. I just can't do that. We have vectors in R4. We just can't draw pictures of them. Okay, so what do I have here? There are 4 arrows on the page there. There's a temptation to say that that's 4 different vectors because, well, look, there's 4 different arrows. We're using arrows to represent vectors. 4 arrows, wouldn't that be 4 vectors? And this is the first sort of subtlety that we need to talk about, and that is, no, this is one vector. So an arrow and a vector are not the same thing. We use arrows to represent vectors. But if you think about it, a vector is just a direction and a magnitude. That's it, direction and a magnitude. An arrow it points in a direction. It has a magnitude, but it also has a location. This arrow is over here. This arrow is over there. They're different arrows because, well, see, there they are. They're different arrows. I could erase one and not erase the other. They're not the same arrows. But in terms of the vector they represent, again, vectors, very importantly, just directions and magnitudes. These 2 arrows point in the same direction. Use your imagination. The art was supposed to be same direction. They have the same magnitude. They represent the same vector. So what we have on the page here, this looks like, again, if you're not thinking about the precisely and subtleties of what a vector is, it looks like there's 4 vectors, but there's not. There's 4 arrows all representing the same vector. One vector, just one vector. Everybody happy? Okay, cool. Alrighty. Okay, so how do we represent vectors in space? So it turns out, well, I guess I kind of skipped over what I need to say next. There is a natural one-to-one correspondence between vectors and points. Now, before I write that down, let me emphasize, I have described vectors and points as very different things, right? A point is a location. It's got coordinates. It's a spot. It's a place. You can point to it. Right? A vector does not have a location. A vector is a different thing. It's a direction. Northwest. Where is northwest. That doesn't have a location, right? It has a magnitude that could be interpreted as lots of different things. So there's no location for a vector. Vectors and points are very different things as such. Okay, but nevertheless, there is a really natural one-to-one correspondence between them. It goes like this. If you have a vector, there's a vector, right? That's 3 arrows. Okay, sure, but that's one vector because that trio of vectors are all pointing the same direction. They all have the same length, magnitude. That vector, that direction and magnitude, I can associate to a certain point in the following way, and the way we do it is we say, okay, we're gonna note that exactly one of these arrows has its tail at the origin. Exactly one, right? If your tail is at the origin and you're an arrow with a certain direction and a certain magnitude, that's all there is. Okay. This is called standard position. This vector here with its tail at the origin is called standard position. For any vector, there is exactly one arrow in standard position. That arrow in standard position has its head at a certain place. That is the point that corresponds to that vector. Right, you give me a vector, there's exactly one corresponding point. And by the way, if you think about it, it works backwards as well. If you give me a point, well, there's exactly one arrow that goes from the origin to that point. That arrow represents a single vector. So anyway, it's interesting that there is this perfect correspondence, a perfect pairing, right? Everybody's got a buddy. For every vector, there's exactly one point, and vice versa. Now, I will admit that this is not the only such pairing. It's possible to pair in a different way, and you could shuffle, and you could go, instead of off of the origin, you could use a different point. Let's not. There's no reason in the context of Math 212 to choose anything other than the origin. So we will always relate points to vectors by way of the origin being where you put the tail. The origin will always define standard position. Okay. Yeah. So, all right. So how do we represent vectors? We already know how to represent points, right? It ends up being super convenient to blur the distinction between points and vectors. We have a way of representing points. We don't really have a way of representing vectors algebraically, right? Vectors are a geometric concept, direction and magnitude. We're representing them with arrows. Those are also geometric concepts. We can draw pictures of arrows, right? But algebraically, how would I represent a vector? And the very convenient choice is to say, well, look, whatever vector you want to represent, green here, there is exactly one corresponding point. We already have a way of representing points. Right? So just tell me what is the point that corresponds to the given vector. Right? So very common to do this. Don't conflate this convenience with a suggestion that somehow points and vectors are the same thing. Of course they're not. Points and vectors are different. But it's awfully convenient to use the same notation to represent them. So the context should always make it clear what you're talking about. If you say, you're at the point 1, 2. Okay, well, what could be more clear? Clearly we're talking about a location. That means 1, 2. If someone says, well, you're moving with velocity 3, 4. Okay, well, sure, it's an ordered pair. An ordered pair you think of as a point, but velocities are not represented by points. Velocities are represented by vectors. So, of course, that 3, 4 means you're supposed to take that point, interpret the corresponding vector. That's the vector that represents your velocity. Okay. Alrighty. Some notation. Okay, let me just do this real quick. But we put a little arrow, hat-looking thing, a little arrow straight over the label to indicate that it's a vector. Very often we'll do that to represent a point as well. So the notation at least in my book, will not always distinguish between whether we're talking about a vector or a point. But the context should. Some books worry about this more than I do and will use triangular brackets. I'm not going to, because I feel like the context should always make it clear whether that refers to a vector or a point. And by the way, here's another thing. Sometimes the coordinates will be written vertically instead of horizontally. And there's a couple of good reasons for this that are admittedly all a little arbitrary, but nevertheless they're still pretty real. And so that's another notation that you're going to see sometimes. So heads up if writing them vertically instead of horizontally with commas. And it appears I am out of time, so we're going to draw the line right there. We did not finish a section today, as I speculated, so there is not going to be any homework due on Wednesday. We will definitely finish at least one, probably two sections tomorrow. So there will be homework due on Thursday. So tomorrow after class, at some point, I owe you an email indicating exactly what sections of homework assignments are due. Okay, see y'all later. Office hours start at 11.